Assalamu alaikum. We are going to discuss about orthogonality of Bessel's function. Previous lecture we have learned that Bessel's differential equation and also Bessel's function. Bessel's function basically is denoted by Jn of x. We have known that. So today we are going to discuss about orthogonality of Bessel's function. At first we can write two differential equation, basically two Bessel's differential equation, x square d square u by dx square plus x du by dx plus alpha square x square minus n square into u equals 0. Similarly, x square d square v by dx square plus x dv by dx plus alpha square x square minus n square into v equals 0. These are two equations like Bessel's differential equation. Here u and v are dependent variable and x is independent variable, and we can also say that these two equations are nth order. The solution of these two equations like u equal to jn of alpha x and v equal to jn of beta x. This is our two solution of these two equations respectively. So we can differentiate with respect to x, du dx equal alpha jn prime of alpha x, and then dv by dx equal beta jn prime of beta x. We will multiply by v by x into equation 1 and u by x into equation 2 respectively, then v by x into x square d square u by dx square plus x du by dx plus alpha square x square minus n square into u, and also subtraction between them, u by x into x square d square v by dx square plus x dv by dx plus, sorry, there will be beta square x square minus n square into v equal 0. Now then the calculation will be v x d square u by dx square plus x is cancelled, then v du by dx plus the multiply with u, that means u v alpha square x minus u v n square minus divided by x, yes, right, minus this part u plus u v beta square x plus u v n square by x 0. Then this term will be cancelled. We can common these two terms. There will be v d square u by dx square minus u d square v by dx square into x, right. Then this term and this term plus v du by dx plus u dv by dx, and these two terms also will be added, u v x alpha square plus beta square equal 0. Actually I am sorry, this sign will be minus and this sign will be minus also. It was my mistake, sorry. And here will also minus and also minus. Okay, we can write this term like this: ddx v du dx minus u dv dx into x. If we differentiate this term, then we will get this term. That means this is the differentiation of this term, and after that plus u vx into alpha square minus beta square equal 0. Now u vx equal, this term will be right side, ddx v du dx minus u dv dx into x, and also alpha square minus beta square will be 1 by alpha square minus beta square after taking the right side. Okay, then integrating with respect to integrating with respect to x from 0 to 1 of this equation, then we will get, if we integrate here also 0 to 1 and also here 0 to 1, then this term 0 to 1, we can write u instead of u equal to previously I said that u is a jn of alpha x and v is a jn of beta x, x into x, equal the differential and the integration will be cancelled, and we can write minus 1 by alpha square minus beta square into v du by dx minus u dv by dx into x, and limit 0 to 1. Now taking the limiting value from 0 to 1, after that 1 by alpha square minus beta square. Now there will be two roots, alpha and beta. Alpha and beta are two roots of jn of x equal 0. This Bessel's equation has two roots, alpha and beta. Now if the two roots are distinct, then we can write, that means alpha not, if alpha not equal to beta, jn of alpha equal jn of beta equals 0. That means alpha and beta satisfy the Bessel's function equation. So putting the values of jn of alpha and jn of beta into this equation, then we will have minus 1 by alpha square minus beta square. This term will be 0 and totally will be 0. That means if alpha not equal to beta, that means alpha and beta two distinct roots of jn of x equal 0. That means we can write 0 to 1 jn of alpha x into jn of beta x into x equal 0. If alpha equal to beta, that means alpha and beta are two equal roots, then this equation will be this form 0 by 0. That means we can use L'Hospital rules. We will take limit both sides. We will assume that b is the root of this equation. So jn of beta equal to 0. Then we will put jn of beta equal to 0 of this equation. Then this term will be 0 and we will have only this term. Okay. Then we will also differentiate with respect to alpha, upper and lower fraction. Then we will have this equation 1 by 2 beta jn prime of beta by beta, alpha equal to beta, and that's why jn of beta, jn square of beta x dx equal to this term equal to 1 by 2 jn prime of beta and jn prime of beta, that means jn prime of beta whole square. Now from fifth recurrence relation we can write jn of x equal to n by x, jn of x minus jn plus 1 of x. Then jn prime of beta equal to n by beta, that means replacing x by beta, then we can write this. But we have known that jn of beta equal to 0, that's why jn of beta and n by beta, this term will be 0. Then jn prime of beta equal to only minus jn plus 1 of beta. And from equation 3 we can write jn square beta of x, that means this term equal to half of, putting the value of jn prime of beta minus jn plus 1 of beta, and here is square, that means we can consider the minus sign. So this is the orthogonality of Bessel's function, where alpha equal to beta of the root of jn of x, that means Bessel's function. Conclude that if alpha not equal to beta, then the orthogonality of Bessel's function will be 0 from 0 to 1, and if alpha equal to beta, that means the root is equal, then orthogonality of Bessel's function will be this term. Thank you so much.